Hi, everyone. Good day. Welcome to General Physics. So, today we are going to discuss the basic principles, the basic concepts in physics, the introductory part of physics. Okay, so we know that physics is a science. Okay, it is part of the natural science. So, we all know that science is actually never ending quest of search for truth, facts, relationship between things, and of course, understanding the laws that runs the world, describing the mechanism of the universe. So this definition of science, it is just but an organized body of knowledge, and this body of knowledge comes from observations and experimentation. Experimentation um, can be done in laboratory, or you can even do experiments using even your mind. Thought experiments, just like with what Einstein did. So, science basically, again, search for observations, and of course, science is a creative activity. Then, important concepts. So, one of the important concepts in science is the observation. So, basically, observation is based on what we can see, but this is not actually limited to what we can see, because Einstein did not limit to things uh, based on what he can see, but he derived his principles and laws based on his thought experiment. So observation, this is basically the designing of the experiment and carrying out of experiments. Then observations requires imagination. Another thing is theory. Theory, basically, this is what we call as educated guess. So this one may be inspired by our imagination, just like with Einstein's theory of relativity. It is being inspired by his thought experiment. And theory basically tries to explain the order and order of observations. So this can be accepted, this can be rejected. Depends on the experiment being carried out. Okay, just like with um, the theory of heliocentricity and geocentricity. So the theory of geocentricity, wherein it is considered that the Earth is the center of the solar system, is being rejected based on the facts gathered by the astronomers. So one of them is the Copernicus. Based on facts, he came up with a theory of heliocentricity, meaning the sun is the center of the solar system. So the Ptolemaic theory is being rejected, and now Copernican theory is being accepted. So we have this model. So next is model. It is a kind of mental image or analogy of phenomena in terms of something what we are familiar with. For example, waves. So um, the common thing related to waves that we can easily associate with is water wave. So water wave, the behavior of wave in water can be likened also to the light waves can be likened to the behavior of water wave. It is quite sinusoidal. Then model of Earth is globe. So it is a mental image. Next is this one. This is what I'm talking about. Water wave. The next is law. So law, this is a statement of fact on how nature behaves. So these are experimentally proven, just like with the Newton's laws of motion, universal law of gravitation. These are experimentally valid over a wide range of phenomena. Okay, so you have this. And when we talk about scientific law are descriptive, while political law is, I mean, scientific law is descriptive, while political law is prescriptive. So when we say prescriptive, you should behave that way, while scientific law, that's the way how it behaves. That's it. Then principle, this is related to law, but it is more specific. It is more specific. Say, for example, when we talk about Pascal's principle and Archimedes' principle, this is under mechanics. Then scientific method, we all know that science follows a step-by-step process on how to acquire new body of knowledge or how to carry out experiments. So we have statement of the problem. So you have to identify the problem. Then next to that, of course, you have to gather information about the problem related to the problem. The information is related to the problem. Then you are going to formulate your hypothesis, or this is your educated guess. The next to that, you have to, of course, to test your hypothesis. So you're going to design experiment, test it, then you have to analyze the data gathered out from your design experiment. Then you're going to draw the conclusion. So if the conclusion is supported, then you have uh, to retest the hypothesis, so that to verify if the same result will be carried out. If it is not supported, then you have to formulate another hypothesis. Then you are going to test again, analyze the data, then draw your conclusion. The same. So it is a cyclic process. So a brief history of physics. Okay, so we are going to go to, say, the ancient period. So we have the prominent philosopher. We have Aristotle. Okay, so this is his contribution. Then we have Leucippus and Democritus, Galileo Galilei. So Galileo actually studied about the movement, how objects behave. Okay, it was his study. However, he wasn't able to organize these things, and it was actually Newton who organized the concept of motion. Then he published that one, and voila, you have there the laws of motion. Johannes Kepler. So he's more on planetary. So, then you have the Robert Boyle. So you have his contribution. Then Isaac Newton. Okay. Isaac Newton has a very wide contribution in physics and also in mathematics. We have Benjamin Franklin. So he studied electricity as well as Michael Faraday. Then we have Maxwell, Fresnel. Then we have Röntgen. So Röntgen and Becquerel, it is more on studies of nuclear physics. Then Planck and Einstein. This is now where the modern physics was born. Okay. So basically, when we talk about science, it is that can be dichotomized into two. We have social science and natural science. In natural science, we have biological and we have physical sciences. Biological sciences deals with matters with life characteristics, while physical sciences deals on matter that has no life characteristics. So under physical sciences, we have physics, chemistry, astronomy, and of course in others, we have geology and all. So we're going to focus more on physics. So physics is a systematized body of knowledge. Of course, it is science. So it seeks to understand the relationship between matter and energy and their interaction. So it is also called to be the nature of the philosophy of nature, because physics wants to understand the fundamental mechanism of nature. Okay, so you have there. Then it is also one of the basic sciences that we have. So we have here the field of physics, we have mechanics, thermodynamics, wave phenomena, electromagnetism, relativity, and quantum mechanics. So for mechanics, it is also sometimes called to be Newtonian mechanics or classical mechanics, because most of the things that can be found in mechanics are uh, basically from Newtonian's idea. So you have there the thermodynamics. So you have thermo, heat, dynamics into motion. So how we are going to utilize heat into useful work. Okay, so wave phenomena. So it understands waves. Why do sound travels? What are the media? Then of course light, the properties of the waves. It is where also optics can be found in electromagnetism, electricity, and magnetism. Before, electricity and magnetism are separate field. However, they found out that they can never be separated. Okay, in fact, Maxwell were able to generate his equations that describing the connectivity, the connection between electricity and magnetism. That is what is called as electromagnetism. Okay. And then relativity, it is more on invariance and high-speed motion. Then we have quantum mechanics. This is a field of physics where it wanted to understand the microscopic world, the world of quarks, something like that. Then uses of physics. Why do we have to study physics? Because we use physics in everyday life. Say for example, if you wanted to travel from your house to school, of course, we have to ride to give convenience to ourselves. And you may not know that the vehicles are actually um, invented because of the idea of physics. That's the thermodynamics. Then physics raised our standards of living. Okay, in what way? Say, for example, before we just use fan made up of, say, paper, made up of how do you call that one? Then right now we are using electric fans, even air conditioners. Then physics protects us from accidents and keep us safe. For example, in your cars, we have here what we call the airbag, wherein whenever there is collision, the airbag will pop out from the how do you call this one? Steering wheel, I guess. Then instead of ramming your head against the steering wheel, the airbag will just protect you out from it. Then physics understand environment. Don't you know that physics also understand, say for example, how do you call it one? The weather. Weather is being updated using the satellites, and these satellites are actually conceived from the idea of physics. Then physics teaches us manipulation and operation of many complicated and simple devices that are necessary in our modern life, just like with our cell phones and all. So we have this communication. Because of physics, we can communicate remotely. And of course, physics gives us profession, career. So you have there. So there's a lot of things that we can derive out from physics. That is why we must learn to love physics. Frontiers. So these are the overlapping fields. So we have biophysics, geophysics, astrophysics, medical physics, engineering, nuclear physics, and all. So I'm not going to deal with this. I'm just going to run through with this. Okay. So geophysics, earth physics, then astrophysics, so you have there. Then medical physics, physics applied in medicine, engineering, and nuclear physics. So physics, mostly we are dealing with problems. That is why we have this general way or ways or techniques on how to solve problem. So we have this didesco. So you have, if you were given a particular problem, you should draw the problem actually to illustrate the problem. Then identify the physical quantities involved in the problem, and of course the principles that can be applied. Then the data, you are going to determine the adequate data that will lead you to finding out what is missing. Then decide whether a particular problem is easier to substitute numerical values, or you can create your own. You can manifest a particular working equation based on the working principles on the problem. Then substitute. If you are already done with the making of the working equation, you may now substitute the numerical values. Then of course compute. And this is basically the techniques on solving problem. So this is just about the same. I'm just going to run through with this. And by the way, in solving problem, as much as possible, do not solve an unknown using solved unknown. So you really have to base on the readily available data. But if there's no other way around, you may use the solved unknown. Okay, so the ability to analyze a problem involves combination of inherent insight and experience. The former, unfortunately, cannot be learned, meaning to say your insight, how you understand, how you make picture of your problem. It depends on an individual, but experience, okay, so you will gain uh, techniques out from your experiences that you have. So you keep on solving problem. By the way, when we talk about physics, do not memorize things. You understand things, okay, so that you will not fall into the difficulty. So the most important thing for the young man to acquire from his first course in physics is appreciation of necessity for precise ideas. Okay, so you have to appreciate precise ideas. So physics talks about, say, things. It talks about matter. It talks about energy. When we talk about matter, we may think of how large, how big, how much. Okay, so we have this questions. Okay, how much is your allowance? So when we talk about how much is your allowance, then you're dealing now with measurement. So in physics, measurement is very important. Measurement is simply defined to be a comparison between a known quantity and a given standard. So standards are actually defined. Okay, so standard is a physical embodiment of unit. What is unit, by the way? When we talk about unit, it, it refers to what particular physical quantity you are dealing with. Say for example, when we talk about meter, unit meter will lead you to a physical quantity which is length. Okay, so you have there. There are methods of measurements that we have. We have the direct method and we also have the indirect method of measurement. So direct method, you're going to apply directly the standard. For example, if you are going to measure the length of a ball pen, you may use a ruler. Ruler basically is our standard. We compare the length of the ball pen in our standard, which is the ruler. The other way is the indirect measurement. So these are basically derived, or this is based on computation. So measurements, physical quantities, we have the fundamental quantities. So far we have 7. We have the length, mass, time, electricity, temperature, luminous intensity, and of course amount of substance. Okay, so we have here the fundamental units, and of course its base unit. So for length we have meter, and you have here the bases. So definition of what is 1 meter. It is based on the standard, which is krypton 86 atom. Okay, so krypton 86 releases what we call this one, radiation, and they measure that one, and you have there the definition of 1 meter, which is equivalent to 1,650,763.73 wavelength. Okay, so next we have here mass. The base unit is kilogram. This is based on the platinum iridium alloy or cylinder, which is preserved. The next we have the time, which is basically from the cesium atom, cesium 133, which is, you have there 9, so you have there 912631770. So this is billion, I think, 9,182,631,770 periods of cesium atom. Next, we have here the electricity or electric current in terms of ampere. Then for the temperature, we have kelvins, absolute zero, absolute temperature, scale. Then luminous intensity. So the unit is candela. How strong the light, the source of light is, something like that. Then we have the amount of substance in terms of mole, and this one basically derived from the concept of from carbon 12. Okay, so derived quantities, these are the quantities which are basically under operation or multiplication or division of the fundamental quantities. For example, we have velocity. When we talk about velocity, it is actually the ratio between the distance or the length over time. That's why you have there meter per second and so on. Okay, so systems of measurements. So far there are 2 systems of measurements existing today. So we have the metric system and we have the English system. So we are going to differentiate these two. So British or English system and metric system. So British English system, under of which is the FPS or the foot for length, pound for mass, and second for time. And for the metric, we have 2, the MKS and the CGS system. C for centimeter unit for length, then gram, unit for mass, then second, and for MKS, we have meter, unit of length, kilogram, unit of mass, and second, unit of time. So, what is the difference between these two? Well, in English system, it is the standard of this is today not existing. Okay, say for example, when we talk about 1 yard, this is actually a distance between the King Henry's finger from the tip of his nose to the tip of his finger. That is defined to be 1 yard, which is equivalent to 3 feet. Okay, so today, that length you cannot anymore reproduce that one because King Henry is already dead. So you cannot reproduce what is 1 yard based on the standard. Next is inch. So you have the barley corns. So 3. Okay, put side by side. Now, that corn is not anymore existing. So it may be higher or maybe lower than how basically. Next is mile. So you have there. So cubit. You have there. So those standards are non-reproducible. Okay, so you cannot reproduce them. Whereas the metric system, the standards are reproducible and preserved. So you have here the metric system is quite easy because the order of magnitude, so you have base of 10. Okay, you have there the prefixes, which will tell you how large the number that we are talking about. Okay, so this is the presidential decree by Ferdinand Marcos, the utilization of the English system. So when we talk about units, there should be agreement of, say, how do you call this one unit into another of the same quantity. That is why there is an idea of conversion of units. So conversion of units, the most important tool that you are going to use in here is the conversion factor. The conversion factor will tell you the equivalent of one unit into another unit which of the same quantity. For example, you have here 1 inch that is equivalent to 0.0254 meters or equivalent to 2.54 centimeter. And this one talks about the unit of length. You may have different unit, but this one will pertain to one particular quantity, which is length. Then the mass also, as well as the pressure. So conversion of units, again, we have here the conversion factors is very important. You may understand them, you may memorize them. Not solely memorize, but understand on how to use these conversion factors. Okay, so you have here. Then sample conversion factor. So you have here 21.5 inches into centimeter. So you're just going to multiply this one with the ratio of the available conversion factor. We all know that 1 inch is equal to 2.54 centimeter. Or you can write this one as 2.54 centimeter over 1 inch. Because we are after of the centimeter unit, we have to put the centimeter unit in the numerator. While since we wanted to eliminate the inch unit, we are going to put the said unit in the denominator so that we can express this one into 1. So you will have 54.6 centimeter. So you are now to erase, or you are now going to cancel out the unit inches. Then another is 1.25 square inch into square centimeter. So you're going to convert that one. So in this one, in this example, in this case, you have the same conversion factor, but you have to square that one so that you will conform to the unit. So you will have 8.06. Then for this part C, you have here 55 miles per hour. This is a series of conversion. So you multiply all the numerator, multiply all denominator, then look into the units that can be cancelled out. Cancel them out. Then you will come up with meter per second. This is the unit of speed. So that's it. So we are going to have more rigorous conversion factor and other concepts of physics and next presentations that we have. That's all, and thank you.